afternoon. I'm Cassie Caslon with Valerian, and on behalf of the project team, I want to thank you all for joining us this afternoon. We're very excited to share the Sanderson Gulch project with you. Of course, this is not how we envisioned this year's CASFM conference to be, and we're really going to miss seeing everybody's smiling faces in person. There's been a lot of uncertainty and change over the last 6 months, but there is one thing that we can all relate to: the COVID mullet. Business on top and party on the bottom. However, as compelling as a mullet may be, we're actually here to talk about a reverse mullet, or tell 'em if you will. Party on the top and business on the bottom. The improvements at Sanderson Gulch in Denver include a sinuous open channel stream with ecological diversity, improved habitat, and water quality, which sounds like a party. All of this is layered on top of a network of braided box culverts for flood conveyance, which is all business. Sanderson Gulch is a complex stormwater system with enhanced open space and stream function for small rain events and box culverts to bypass large storms. These improvements result in the containment of 100-year storm flows and removed 107 parcels, including 102 structures, from the regulatory floodplain, reducing risk for businesses and residents in the area.
I'd like to orient you on where we're at in the city and county of Denver. Right now we're at Sanderson Gulch's outfall to the South Platte River. And Sanderson Gulch is a tributary channel to the South Platte River. The project extents that we're here to talk about basically goes from the confluence where we're standing right now up to Sanderson Gulch Park, which is near LePan Street. To the south of the project location, you have Florida and the Ruby Hill neighborhood, and to the east, you have Overland Pond Park. That orients you about where we're at in the city and county of Denver and where this project took place. But what I want to talk to you about is the existing conditions before we got to this point here. And what the channel was through this highly industrialized area had undersized culverts. It crosses a BNSF bridge that was dilapidated and looks like it was ready to fall into the creek. And then the channel and the culverts from LePan on down were basically undersized. So we ended up with overtopping of LePan Street and South Platte River Drive on a frequency of a 10-year event. So we knew that we had a highly constrained, channelized section that had frequent flooding history for this particular area. After the 2013 floods, the city and county of Denver had identified this as an area where they'd like to reduce flood risk. So the city's primary goals here was to reduce flood risk, increase conveyance capacity, and really elevating the high-functioning, low-maintenance stream in a highly urbanized areas. Some of the secondary goals as we got down into the final design was increasing the water quality in the area via trash faults and or just through the vegetation in the channel that we created upstream of the outfall. The city applied for a hazard mitigation grant, and through a string of events in the design process, they were able to secure about $7.2 million worth of funding, which kind of greenlit the design of the project. So at that point, the Mile High Flood District partnered with the city and county of Denver. Icon Engineering developed a fantastic project team to really take a holistic approach of looking at how to make this corridor better. And really all of these goals needed to be achieved while adhering to all the federal and state grant requirements on a very strict timetable and schedule, both for design and taking it through construction. The design team and really a collaborative approach between the Mile High Flood District, the city, and a bunch of other cooperating agencies was able to come up with a flood control project that achieved the goals of taking people out of the floodplain, but creating a corridor that would be an amenity and really just enhance the overall area when we are done.
Hi, I'm Aaron Busolo with Icon Engineering, and I'm going to share some details about the design considerations and engineering approaches for this unique project. I'm at a location near the center of the site between existing buildings and near the BNSF railroad tracks, and I brought my security badge just in case. You can see this is a very narrow corridor, and the existing drainage easement through this area is even smaller. This presented several challenges for finding a feasible design and completing the construction. The project design team looked at many alternatives for coming up with a plan to convey a large amount of stormwater through this confined space. We looked into possibilities for nearby land acquisition and feasibility for the addition of more upstream detention to reduce the peak flows. These alternatives were found to be cost prohibitive and too time consuming for the project and grant timeline. Additionally, we evaluated many culvert arrangements and bridge replacement options for the railroad and 2 roadway crossings through this reach. Several variations of high-capacity open channels were considered as well. Unfortunately, these options included tall retaining walls with confined channel conditions, significant flow depth with high channel velocities and shear potential, future maintenance challenges, and other safety concerns. And the project goals were just not being met. The design team recognized that more innovation and creativity was necessary. We started developing a concept that includes functional open space with an active channel that also includes a complex stormwater bypass system below it for safely conveying larger storm flows. The design elements became complicated, and as part of the process, we developed 3D design models for the large network of culverts and for the boulder structures in the channel. This allowed the team to envision scenarios and figure out the best configurations for design. It was also helpful to provide these visual aids to the contractor for construction. Let's take a closer look at the new stormwater system with a digital flyover. The project includes a signature boulder outfall structure at the South Platte River and a meandering multi-stage channel with diverse vegetation. Below the channel and road crossings is a network of culverts that are important for providing capacity to convey large flows. At the upstream end of the project, Sanderson Gulch changes from an old concrete line channel into a new step pool structure and naturalized channel. As flows approach South Lipan Street, a complex drop structure diverts the base flows and small storms into a water quality vault and 12x3 box culvert. This low flow culvert extends below the roadway and railroad and daylights to the natural channel downstream. Then at South Platte River Drive, the low flows are conveyed through 5 2-foot tall box culverts and cascade onto the South Platte River outfall structure. The low flow portion of this system is anticipated to convey a maximum of 600 CFS, which is less than a 10-year storm recurrence. During major storm events, the upstream boulder structure redirects high flows into 2 14x8 box culverts. These high flow culverts transition to 4 16x4 box culverts underneath the low flow channel. Total capacity for the combined system is around 4,500 CFS, which will allow for future storm outfall projects upstream and accommodate future 100-year flows. At the outfall to the South Platte River, the channel acts as a waterfall from the upper culvert cells and splashes into a center pool. The flows then spill laterally and fill the lower pools on both sides. These pools help dissipate energy, collect sediment and debris, and also serve as a deterrent for culvert entry by people, although the crawdads and minnows seem to enjoy it. Finally, there are several flow paths for water to cascade through the slabstone boulders and down into the river.
As Aaron mentioned, we went through many design iterations to land on the concept for the project. We also went through many iterations to land on the aesthetic design for the project. So as you can see, we've got these very large boulders throughout the entire project. These are a common theme that we use to tie the whole project together. So we began the design process by looking at various material options, including sculpted concrete, standard granite boulders, just standard concrete with form liners. And we finally decided that we really needed to push the limits here. And we decided on these quarried slab stones that are actually all sandstone. So we visited multiple quarries and did tests on multiple different types of rocks. And we landed on this product that actually met the structural requirements of the project as well as the aesthetic look that we were going for. So in addition to the boulders, we wanted to really make sure that we were pushing the limits and making sure that we were fusing the natural environment with the South Platte and the meandering open channel with the really urban corridor that this project is located in. We took a look at the concrete walls that we were using for the wing walls and the box spaces, and the design team really pushed ourselves to figure out how we could incorporate that piece of the design with the boulders and the sinuous stream. That's how we ended up curving all of the wall faces that you see, both here at the Lipan structure and down at the South Platte structure. Throughout the entire design process, we constantly considered how people were going to be using this space. We knew that there was going to be a lot of people in and around these areas. Up here at the Lipan side, we are in an existing park with an existing trail system in an existing neighborhood. So we knew that people were going to be here. While we knew that we wanted this project to be an aesthetic amenity to the community, it is a stormwater facility, so safety was a constant concern. We incorporated many design features to promote safety to the best of our ability. There is an existing trail here at the Lipan side. We realigned it to keep it away from the box culvert. We added a fence and handrail at the top of the box culvert. And in addition to that, we integrated a wetland bench and rough plants that were chosen for their harsh characteristics to prevent people from cutting down from the trail to the box culvert itself. Prior to this project, there was no direct pedestrian connection between the intersection at Florida Avenue and the South Platte Regional Trail. But there was a very well-established social trail. So in order to keep pedestrians safe and prevent unintended trails from forming, this trail connection was formalized and the decorative handrail was added to the top of the outfall to help direct pedestrians. So as you can see, we did incorporate a lot of different features, ranging from the standard railings to a more integrated approach with the vegetation. Josh is now going to be sharing a little bit more about our approach to vegetation.
Hello, I'm Joshua Eldridge with Great Ecology. I'm standing in what's called Mid-Gulch. This is the section of Sanderson Gulch that is directly over the concrete box culverts you just learned about. The vegetation you see around me is less than a year old and contains more than 30 native species, most of which are seeded or planted. The meandering low-flow channel is comprised of void-filled riprap and wetland sod and replaced with rock-lined linear channel. The bottom of the low-flow channel is approximately 18 inches above the concrete box culverts, and the top of the slopes are about 4 feet above the box culverts. The design is highlighted by 3 overbank swales like this one that provide water quality benefits as well as habitat diversity. The corridor is fairly narrow and short, only about 400 feet long by 80 feet wide, but we were able to fit in a lot of natural features. We really helped provide resilience against the flashy storm hydrographs that this watershed sees. What we were able to do is create a multi-stage channel that is really able to slow down the water and spread it out so that we can contain some of the sediment that moves through this watershed. We've had multiple storm events this season that saw these basins fill with sediment, and yet the plants were able to pop right back up and seemingly unaffected. We've also seen the added benefits of wildlife habitat. We've seen killdeer, lizards, snakes, rabbits all call this watershed home, as well as countless raccoons and waterfowl. One other cool feature about this project is we were actually able to build in a series of test plots testing the effects of wood chips incorporated into topsoil to affect native species establishment. We utilized wood chips donated by Denver Parks and Recreation at a ratio of 1 part wood chips to 4 parts soil to manipulate soil chemistry. The wood chips were mixed by the landscape supplier and then placed in alternating test plots where we had no wood chips and wood chips. And we alternated that throughout this corridor. That was the only part of the design that changed. All other features of the design, including seed mixes and plantings, all stayed the same. And the effects are pretty apparent. No wood chips, wood chips. No wood chips, wood chips. You can tell that we have an increase in native forb establishment, fewer noxious weeds, and higher native grass cover in the wood chip plots. The value of this research is that it provides a new tool for land managers and natural area designers to be able to improve native species establishment with less fertilizers and control weeds with less herbicides. Ultimately, this project is going to be non-irrigated. But fortunately, the project partners, and in particular Mile High Flood District, were willing to support temporary irrigation to help establishment. And it was a huge deal in helping get plants established this year. Establishing vegetation quickly is imperative to creating high-functioning, lower-maintenance systems within riparian management zones. Designing a non-irrigated site with increased ecological function was just one of the challenges that we had with this project. Now Terry's going to tell you more about the construction challenges that we faced.
Construction of the project started in May 2018 with substantial completion in December of 2019 at a total project cost of approximately $15 million. The project team faced some unique challenges during construction, which I'm here to discuss. First and foremost is water control of an active stream at the bottom of a 7-square-mile, highly urbanized watershed with a 100-year discharge of approximately 4,100 CFS.
This required a phased approach to the stream diversion. For phase 1 of the diversion, the contractor decided to keep the base flow channel in place while excavating up to 10 feet deep on either side of the active channel as shown here. This allowed them to construct a portion of the box culverts on one side of the stream while building a new diversion channel on the other side of the stream. Unfortunately, this decision was prone to setbacks, as this midsummer flooding event shows. Rain events of this magnitude were fairly common in the summer of 2018, and this event alone caused a near 3-week delay to construction activities while cleanup was performed. Once their Phase 1 diversion channel was in place, it allowed them to begin excavating the remaining channel section and constructing the box culvert, which once again was not without its problems. Finally, in November 2018, the contractor instituted a pump diversion consisting of 3 12-inch pumps to handle the base flows and small storm events, which also was not without its problems. Here's a quick video of the bomb cyclone event in March 2019. One useful feature of the design was the incorporation of a rat slab underneath the box culvert. This slab provided a stable base on which to work and was also immensely helpful during cleanups. The box culvert was then constructed on top of the rat slab. Once the far south cell of the quadruple box culvert was constructed for the length of the gulch, flows were then shifted to that cell, and the remaining 3 cells of the box culvert were constructed. The second major obstacle was the replacement of the failing BNSF railroad bridge. Coordination with BNSF on a shutdown date took approximately 9 months. This bridge was replaced by a double 14x8 and 12x4 RCBC in order to convey the 100-year discharge. This work was performed around the clock from a Wednesday starting at midnight, finishing by late Sunday afternoon in February 2019. Another major complication was the presence of multiple contaminants on the site. In addition to asbestos, the groundwater was contaminated with uranium, and it was also a former Superfund site which functioned as a radium processing facility during World War I and World War II, making glow-in-the-dark watches, among other things. Facilities such as these were written about in a book and upcoming movie called The Radium Rules. Although the site was remediated in the 90s, some radium tailings remained which the project was responsible for. As a result, radiation technicians were on site throughout the project scanning with Geiger counters to detect spikes in the background gamma radiation level. In this case, the techs were scanning an area that was contaminated with both asbestos and radium. Any soil encountered with a gamma radiation level over 30 microrentgens per hour was segregated and typically hauled to Clean Harbors in Deer Trail, Colorado. In this instance, a higher level of radium was discovered in this rock, which had to be disposed of at a facility in Louisiana, costing approximately $10,000 just for this single rock. I should mention that overall residual gamma radiation levels were very minor, typically just over the EPA threshold of 5 picocuries per gram of soil. In fact, you'd get a higher dose of radiation by eating approximately 22 bananas than you would from the site.
The quartzitic sandstone boulders are certainly a highlight of this project, but installation was not without some complications. Arranging the irregular blocks to complete the puzzle was difficult at times. Icon Engineering and Valerian devoted close to full-time staff on site to support the boulder placement effort. Overall, this project required an extraordinary amount of teamwork and coordination to accomplish the goals we set. One great example is the Mile High Flood District helped streamline the site stabilization and revegetation effort by contracting the work directly with Habitat Management. Their expertise and assistance with pre-growing and installing wetland sod and plantings was essential for the channel's success. So as you can see, we've achieved a lot with this project, and a few accomplishments that stand out in our minds are: we have a stormwater system that removed over 100 properties from the floodplain.
We provided trail connectivity for South Platte River Trail users.
The project delivers cleaner water to the South Platte River and increases ecological diversity.
We really pushed the limits with creative design.
And all those things are great, but we really had two primary goals, and I think we've came here and accomplished it. One was to prove to you that we should win the CASFM Grand Award for Excellence, and two, we really accomplished our reverse mullet.